Okay, now these work problems, I wouldn't necessarily say they're harder than the problems that we did yesterday or the problems that we've done using charts before. They're just different, okay? Just like with most word problems, we're going to set up a lot of the ones today the same way, a lot of the ones in your homework the same way. So I'm going to really break down the first one. We're going to take it very, very slow because there's kind of, like I said, it's just new. It's different, okay? So I'm really going to break down the first one. So if you have questions, if that first one does not make sense to you, you need to stop me, raise your hand, and I can try to explain it a different way, okay? If you look at your 3 charts that I gave you, notice that the top equation is the same for all of these. We're talking about work problems. So I have a certain job, and I can do this job at a certain rate. So if I can finish half of the job in an hour, right, my work rate would be 1/2, okay, because I can finish half of the job in 1 hour. So if I work for 2 hours, I would finish the entire job. So that's kind of to make sense of that equation that I have at the top, okay? A lot of these today are going to be 2 people doing the same job, but they work at different rates. And I want to know how fast they could do the job together, or if they can do the job together working this fast, how long would it take just one of them to do this particular job? Okay? So like I said, just different, so please ask questions. I'll really try to break down this first one for you guys. Okay, so number 1 says one printing press can finish a job in 8 hours. The same job would take a second press 12 hours. How long would it take both presses together? Okay, so instead of thinking about this as 2 printing presses and they're printing some job, let's kind of put an actual physical idea with this. Let's say we have 2 different printing presses. They're going to print a book, okay? If the first printer prints it all by itself, it would take 8 hours. Okay, so I'm just going to write that kind of off to the side. If the second press prints it all by itself, it would take 12 hours. So instead of having them print separately, I'm going to have them both help print the book so it goes faster. I want to know how long is that going to take them. Okay, so this first thing we're going to look at is this work rate. Okay, this work rate in this particular problem is going to be how fast each press will print in an hour. So if we think about that first press, it would take this first press 8 hours. In 1 hour, one of those 8 hours, how much of this book would the press print?
1/8.
1/8 of the book. If it takes 8 hours, in one of the hours, it'll print 1/8 of the book. Okay? Similarly, the second press, if it takes 12 hours, in one of those hours, how much of the book could it print? 1/12. Okay, a lot of this stays the same for a lot of the problems today. Does that make sense? Okay, now sometimes we're not always going to be talking about hours. This is going to be rate per hour, how much of the job we can get done in an hour. But we could also change it to working with minutes. So if your problem instead is talking about it takes 30 minutes to wash the dishes. A lot of dishes, I guess. Okay, so if it takes 30 minutes to wash the dishes, we could say that in 1 minute, you would finish 1/30 of the dishes. Okay, now the only thing you have to be careful of, if I'm going to talk about 1/8 as in hours here, this time has to be hours. If I'm going to talk about 1/30 of the dishes in minutes, this has to be minutes too. Okay, does that make sense? Doesn't matter which one you use, but you do have to stay consistent. Okay, everybody understand the work rate? Like I said, that kind of stays the same through all of these. Okay, now for the time. I don't know how long it takes them to print together. So this time that we're looking at here, this is the time it's going to take them to print together. How long they would be running, okay? Now, I don't know how long it's going to take them together, but assuming they start at the same time and they finish at the same time, they would print for the same amount of time. Agreed? Okay, right? If you start at the same time and you finish at the same time, it would be the same amount of time. So if I say the first press would print for X hours, how long does the second press print for? X hours. The same amount. They have the same time. And then just like with all the other charts, to fill in that last column, we're going to multiply across. So I have 1/8 x, and I have 1/12 x. Okay, so filling out the chart really wasn't too bad. Just kind of one new thing with the work rate. Okay, everyone with me so far? Not too bad. Okay, now I have to write an equation. Okay, and this is another new part. Let's kind of interpret our table and see what it means. So this is work done. So in this particular problem, this last column represents how much of the book each press prints. So this 1/8 x, that's how much of the book, that's how many pages, what percentage, what fraction of the book that first press will print. This 1/12 x, that's how much of the book the second press will print. Okay? So if I take this much of the book with this much of the book, how much of a book do I have? A whole book. One whole book. So that's what we're going to do to write our equation. I'm going to take the amount of work printed by the first press and add it to the amounts of work done by the second press, and I get one whole project, one whole book. When I look at this equation, it doesn't make sense to me. I'm like, what? You gotta be kidding me. But if you break it down, it does make sense, but the equation just looks kind of funny. Okay, does that make sense? Okay, well, this is all the same stuff we've been doing. I have an equation with fractions. I don't want an equation with fractions. How would you get rid of that 1/8 and 1/12? Okay, multiply by the least common denominator, which would be 24. Now remember, this is the thing that a lot of people are doing, which is a very common mistake. Whenever I multiply by 24, I have to multiply the left side by 24 and the right side by 24. Can't forget about that right side. So I'm going to take 24 times 1/8 x plus 24 times 1/12 x equals 24 times 1. And then hopefully my denominators cancel out. So for that first one, I can divide out an 8. And I'm left with 3 times x. For my middle term, I can divide out a 12. And I'm left with 2 times x, which gives me 2x. And 24 times 1 just gives me 24. And 3x plus 2x gives me 5x. Divide both sides by 5. Should get 24 over 5. Now, normally I tell you, I don't care if you leave it as an improper fraction. I don't care if you change it to a mixed number. But if we're thinking about this, right, this is how long it takes them to print together, how long it would take them to print the entire book. Does it make a lot of sense? It takes them 24/5 hours. No, you don't really think about time in terms of an improper fraction, so it would be more appropriate in this problem to change it to a mixed number. So 24 over 5 as a mixed number would be what? 4 4/5 hours. Because now whenever I see it written like this, I can see, okay, it takes them about a little less than 5 hours to print the entire book when they're both printing together. Yes?
Can you change the 4 or 5 to minutes?
You could, if you wanted to. Don't have to, but you could. And that would make it even more relevant, right? Make a little more sense. Okay, questions on number 1? Not too bad. Like I said, not necessarily hard, just kind of different. Okay, we're going to set up all of these 1, 2, and 3 just a little bit differently, hoping to kind of prepare you guys for your homework. Okay, so number 2 this time instead, we're talking about a mail handler. This mail handler needs 3 hours to sort on average, an average day's mail. But with an assistant, it only takes 2 hours. I want to know how long would it take the assistant to sort the mail working alone. Okay, so if it's just the mail handler, it takes them 3 hours. So whenever you're setting up the rates, when you're setting up the work rate, that work rate is the mail handler's work rate alone, not when he's working with the assistant, just his work rate. So if he can sort the entire day's mail in 3 hours, how much of the mail could he get done in 1 hour? A third. He can get a third of the mail sorted in an hour. Do I know how long it would take the assistant?
No.
Okay, I don't. So that would probably be a good place for our variable, right? It's going to take the assistant X hours to sort the mail. Okay, now hopefully you're kind of starting to figure out a pattern. May not make a lot of sense, but if it takes the assistant X hours to sort the mail, how much of the project could he get done in one of those hours? 1 over X. Does that make sense? So 1 over X. So his work rate is 1 over X. Okay, now this time is how long they're working on the scenario we're talking about. So the scenario we're talking about is if they're working together, it takes them 2 hours. Okay, so not talking about just the mail handler or just the assistant anymore. We're talking about when they work together, it takes them 2 hours. So how long does the mail handler work? 2 hours. How long does the assistant work?
2 hours.
2 hours. And then just like before, multiply across. So the mail handler gets 2/3 of the work done in this time. The assistant gets 2 over X amounts of the work done in that amount of time. Okay, once again, this is how much the mail handler gets done. This is how much the assistant gets done. If they're the only two working, when I add their 2 piles of mail that they've sorted together, I get 1 whole, right? The entire mail that they had to sort. Okay, and then once again, once you set up your equation, we're going to go ahead and solve. So I want to get rid of those fractions. So what would I multiply by? 3x. Once again, I'm going to say this every single time. Make sure you multiply everything, absolutely everything, by that 3x. Okay, so we have 3x times 2/3 plus 3x times 2 over x equals 3x times 1. And go back through, cancel out your denominators. X times 2 gives me 2x. Can divide out an x. 3 times 2 gives me 6. And then 3x times 1 just gives me 3x. Okay, I have x's on both sides of my equal sign. To get them in one place, we would subtract 2x from both sides. And I get 6 equals x. Which is great and wonderful, and hopefully most of the time that's my actual answer. But let's make sure. What does x represent? Right, isn't that what we said at the very beginning? It takes the mail handler 3 hours. We didn't know how long it would take the assistant, so we said it takes him X hours, and that's what we found. It would take the assistant 6 hours to sort all of the mail. Any questions on number 2? Ready to move on to number 3? Last one. All right, it takes my father 3 hours to plow our cornfield. His new tractor. Using the old tractor takes me 5 hours. If we both plow for 1 hour before I go to school, how long will it take me to finish plowing? No? Okay. Okay, so.
6 3/4 of an hour.
Okay, so this one's going to be set up, like I said, just a little differently. They'll all be set up just barely differently. So if we read through this, we said it takes the father 3 hours. If he were to work all by himself, it would take him 3 hours to plow this cornfield. So in 1 hour, how much of the cornfield could he get done? 1/3. Me, it would take me 5 hours, of course, only because I'm using the old tractor. If I was on the new tractor, of course I would get it done just as fast as, Anyway, okay, so if I can get it done in 5 hours, in 1 hour, how much could I get done? 1/5. Okay, now for the time. Do I know how long it would take how long it's going to take my father to finish? Do I know how long my father plows altogether?
Yeah.
Do I? No, I don't. Do I know how long I plowed or how long I worked? Read through what you're given. Does it tell you how long you worked? Or me or whoever we're talking about? How long did I work?
An hour?
I worked an hour and then I went to school. So my time is an hour. Okay, now I do not know how long my father worked, right? And keep in mind, we're looking for total time. Okay, so my father works for a certain amount of time that we don't know, but he also worked that hour with me. So if we're looking at total time, he worked a certain amount of time by himself, and he also worked an hour with me. Does that make sense? Okay. And then the rest of this is the same. We're going to multiply straight across. So we take 1/3 times x plus 1. And 1/5 times 1 just gives me 1/5. Okay, so if this is how much my father can get done, and this is how much I get done, when we're finished, we plowed one whole cornfield. Okay? And once again, I really don't want to deal with those fractions, so what would I multiply by? 15. So we're going to take 15 times 1/3 times x plus 1. And 15 times 1/5. And don't forget about that right-hand side. 15 times 1. And if we cancel out our denominators, I have 5 times the quantity x plus 1. The 5's cancel out, and I'm left with plus 3. 15 times 1 just gives me 15. And if I distribute the 5, I get 5x plus 5 plus 3 equals 15. Simplify both sides. You have 5x plus 8 equals 15. Subtract 8 from both sides. You get 5x equals 7. Divide both sides by 5. And once again, to kind of make it make more sense, if we change this into a mixed number, we would say 1 2/5 hours, or about 1.5 hours. It would take my father an additional 1.5 hours to finish the job. Okay, any questions?